Hello viewers, I am K. Ramesh Babu, Associate Professor in Physics Department, and then our department is Department of Freshman Engineering. I am working in St. Martin's Engineering College. Today I am going to explain about this a laser that is called helium neon laser. Before going to discuss about helium neon laser, I want to give background of a laser. Okay, laser is the acronym for light amplification by stimulated emission of radiation. So why we are talking about laser? Because laser has got a special characteristics when compared to ordinary light source. In fact, laser also a light source, but it has got special characteristics when compared to ordinary light source. The special characteristics of laser are as follows. The first property of laser is high monochromaticity. Here the term monochromaticity stands for single color, that means single wavelength. In fact, the parameter monochromaticity is identified by the parameter bandwidth. We know that sodium lamp, the ordinary lamp, sodium lamp will have a monochromaticity of bandwidth of delta lambda equal to 8 angstroms. But if you take the case of laser, the bandwidth of laser beam is much less than 1 angstrom. So the bandwidth is much less than 1 angstroms in case of laser. That is one important property of a laser. That is why we say that laser is a highly monochromatic source. And the second property is directionality. Remember that ordinary light source propagates in all directions, but laser is a light source that gives light only in one direction. And in fact, the parameter directionality is given by the angle of divergence. Ordinary light source will have divergence angle of few degrees, but the laser beam will have divergence angle of much less than 1 degree. So the divergence angle of laser beam is much less than 1 degree. That is why we say that laser is a highly directional laser beam. And the third property is intensity. We know that intensity is defined as the total energy of photons passing through unit cross-sectional area per unit time. In case of ordinary light source, the number of photons that are passing through unit cross-sectional area will be very less. Therefore, the intensity of ordinary light will be very less. At the same time, the intensity will decrease as we go away from the light source. But in case of laser beam, the number of photons passing through unit cross-sectional area will be very high and it will be constant as we go away from the center of, as we go away from the light source. That is why we say that laser is having very high intensity. Then the next property is coherence. The term coherence indicates the coordinated motion of waves. In case of ordinary light source, the waves from ordinary light source, they don't move in the same direction and they don't maintain constant phase difference. So ordinary light source is considered as highly incoherent. But whereas in case of laser beam, the light source produces waves and the waves maintain constant phase difference throughout their path. That is why we say that laser is a highly coherent laser beam. So in this manner, the laser is having high monochromaticity and it is having high directionality and it is having high intensity and finally it has high coherence. And because of these special properties, the laser is used in almost in every field. We find applications of laser in almost every field. We find application of laser in communication field. We find application of laser in medical field. We find application of laser in computers field. We find applications of laser in industry and we find the applications of laser in scientific field and we also find application of laser in military. So because of these special characteristics, the laser is having that many applications. So this is the background of laser. Now we discuss about the light sources, the laser sources that are available in our daily life. We find the laser sources in laser shows, and we find the laser sources in laser scanners, and we find the laser sources as pointers. So these are laser pointers. So these are the laser sources we find in our daily life. Now with this background of laser, now we discuss about helium neon laser. Helium neon laser is invented by the scientist Ali Javan in 1961. And the features of this helium neon laser are as follows. First of all, it is an example of a gas laser. So the first laser invented by the scientist T.H. Maiman is a solid state laser that is invented in 1960. This is the second laser invented in 1961, and it is an example of a gas laser. And remember that this is a 4-level laser, and then it is having a wavelength of, it gives a laser beam of wavelength 632.8 nanometers. This wavelength lies in the red spectrum of red color. This corresponds to red color, and finally it will give you a continuous laser beam. So that is why we say that it is used in CW mode. CW mode means it is operated in continuously working mode. So these are the special features of laser beam. Now we discuss about the construction of this laser. So let us concentrate on the construction of this laser. This laser contains a specially designed discharge tube. This central figure is the specially designed discharge tube, and we find that the end faces of this discharge tube, they are cut at a particular angle, and these end faces are called as Brewster's windows. Because of this special design of the discharge tube, we get highly polarized laser beam from this source. And this discharge tube is fitted with 2 electrodes. One electrode is called as cathode and other electrode is called as anode. And this cathode and anode, they are connected to a high tension power supply as shown here. And this discharge tube is filled with helium and neon gases in the ratio of 10:1. And then this, of course, we maintain a low pressure, and here 10 parts are helium and only 1 part is neon. Then this discharge tube is placed between 2 reflecting mirrors. Out of these 2 mirrors, this left side mirror is 100% reflective mirror, 100% reflective mirror, and the right side mirror is partially reflective mirror. And finally we get laser beam from this partially reflecting mirror as an output. Of course, we get the laser beam of wavelength 632.8 nanometers from this partially reflecting mirror in the form of output. So that is about the construction details of this laser. Now we look at the working of this laser. So we can understand the working of this laser with the help of energy level diagrams. In this figure, we have energy levels corresponding to helium atoms on the left side, and on the right side we have energy levels of neon atoms. And here we find that the helium atoms are having 3 energy levels denoted by He1, He2, He3, and the neon atoms are identified by 6 energy levels which are denoted as Ne1, Ne2, Ne3, Ne4, Ne5 and Ne6. And one more thing we observe is the He3 level of helium atoms is exactly coinciding with Ne6 of neon atoms, and He2 of helium atoms is coinciding with Ne4 of neon atoms. Okay? So that is what we observe from this energy levels of helium atoms and neon atoms. Now, as I told already, we apply a high tension power supply. That means we connect a high tension power supply across the 2 electrodes, and we apply a high voltage between the 2 electrodes. the high voltage between the two electrodes produces a discharge, electric discharge it will produce. The electric discharge means flow of electrons. The flow of electrons will take place from cathode to anode. The flow of electrons collide with the helium atoms first. Actually, the gas contains both the atoms, but here helium atoms are lighter atoms when compared to neon atoms. Because of this lightness of helium atoms, the electrons will excite the lighter helium atoms to higher levels. So first of all, the helium atoms are excited to higher levels. Some helium atoms are excited to He2 level, some helium atoms are excited to He3 level. So in this way, the helium atoms are excited by the electric discharge between the two electrodes. Now this excited helium atoms, they transfer their energy to the neon atoms. So how they transfer? Because there will be always collisions between helium atoms and neon atoms. The collisions cause transfer of energy from large number of helium atoms to the small number of neon atoms, and because of the collisions, the energy of helium atoms are transferred to the neon atoms. As a result, there will be transfer of energy from helium atoms to the neon atoms, and there will be transfer of energy from He2 level to neon atoms and after transferring energy, the helium atoms return to the ground level, but at the same time the neon atoms are excited to Ne4 level, Ne6 level because of the transfer of energy. Now after exciting the neon atoms, immediately we find the population inversion condition between Ne6, Ne5, and we find population inversion condition between Ne6 and Ne3, and we find population inversion condition between Ne4 and Ne3 levels. So there are three population conditions are satisfied. After getting population inversion condition, then a spontaneously emitted photon that is traveling along the axis of the discharge tube triggers the stimulated emission. And the photons due to stimulated emission, they cause more and more stimulated emissions, and the photons due to stimulated emissions, they travel along the axis of the discharge tube, and because of the mirror system, they move back and forth between the mirrors, causing more and more stimulated emissions. As a result, the intensity of light increases within the medium, and when the intensity sufficiently builds up, there will be emission of laser beam from the partially reflecting mirror. But here, three population inversion conditions are satisfied, so there occurs three laser transitions. One laser transition is between Ne6 and Ne5 at a wavelength 3.39 micrometers. The second laser emission takes place because of the transition between Ne6 and Ne3 levels at a wavelength 6328 angstroms, and the third laser transition takes place between Ne4 and Ne3 levels at a wavelength 1.15 micrometers. In this manner, we get three laser beams from this light source, but out of these three laser beams, we find that only 6328 angstroms lies in the visible region, and this corresponds to red color. So we get a red laser beam from the laser source, and these 3.39 micrometers, 1.15 micrometers, they lie in the infrared region and they are not visible. After emitting laser beams, the neon 5 atoms and neon 3 atoms, they return to Ne2 level. But here Ne2 level is a metastable state. Therefore, the neon atoms reaching Ne2 level, they may stay for a longer time. So to avoid this, the discharge tube we made as narrow as possible. Actually, we taken the discharge tube in the form of a long tube of 80 centimeters length and 1 centimeters wide. And because of that narrow cross section, the neon atoms reaching Nu2 level, they collide with walls of the discharge tube, and finally they return to ground level Ne1. So there will be de-excitation of neon atoms from Ne2 to any one because of the collisions with walls of the discharge tube. In this manner, the neon atoms are excited to higher levels and they are causing 3 laser beams and they are returned to the ground level, and this process is continuous. So we get a continuous laser beam from these neon atoms. And one more thing I want to mention is, whatever helium neon lasers available in market, they produce only one wavelength, not 3 wavelengths. That means we have to remove the additional wavelengths like 3.39 micrometers, 1.15 micrometers from this source. We can remove this wavelengths 3.39 micrometers, 1.15 micrometers using by some optical methods. The optical methods include intracavity etalon or a prism. So these optical methods we can use to eliminate the wavelengths 3.39 micrometers and 1.15 micrometers. Finally, we get only one wavelength from the laser beam. So, and that wavelength is 6328 angstroms. So in this manner, we can explain the working of helium neon laser with the help of this energy level diagram. Now we look at the applications of this laser. Okay, now I will explain the applications of helium neon laser. The applications are like this. The first application is they are used in laboratories to conduct interferometric experiments. Helium lasers are used in supermarket checkout counters to read the barcodes. The helium neon laser scanners are used for optical character recognition, and helium neon lasers are used by newspapers to reproduce the transmitted photographs. And then we can use the helium neon laser in metrology for surveying and as a alignment tool. Then we can use it in guns for targeting. So to target an object, we use laser beam to along with a gun. So that is one application. Then they are used in 3D recording of objects, that is called holography. Holography is a field that is used to produce 3-dimensional photographs. In that photographs, we use laser beam to have 3-dimensional photograph, and of course to view the 3-dimensional photograph we require the laser beam again. So these are some applications. Now I want to tell about the components of a helium neon laser. So I will explain what are these components. Any type of laser definitely will have 3 components. The first component is active medium. The first component is active medium, and the second component is pumping system. And the third component is optical resonator. Is the third component of the laser. Any type of laser definitely will have these 3 components. Now we try to understand what is this active medium. So active medium is the medium with suitable energy level system in which population inversion can be achieved. Active medium is the medium with suitable energy level system in which population inversion can be achieved. And in this particular laser, helium neon laser, the active medium is nothing but the mixture of helium and neon gas. Helium and neon gas. Helium and neon gas is the active medium in this laser. Actually, we can say that neon atoms are the active centers because they are giving the laser beam. Then the pumping system. The pumping system is the method to get population inversion in the method, in the medium. In this laser, we are getting population inversion because of the electrical discharge. So the electrical discharge between electrodes, causes the population inversion in the material. So the pumping system is nothing but electrical discharge in this helium neon laser. And the third component is optical resonator. And here we are using a pair of mirrors, and the pair of mirrors constitutes optical resonator. So the pair of mirrors we arranged, they constitute the optical resonator part. Optical resonator is the component, it is to eliminate the spontaneously emitted photons and to provide direction for the laser beam and to have multiplication of the photons. For that purpose, we use this pair of mirrors. So we say that optical resonator is constituted by pair of mirrors. So that is about the three laser components. Now finally, we look a small video to explain this class topics. So now I will show that video. Okay, so this is showing the helium neon laser. In fact, the helium neon laser contains the mixture of helium and neon gas, and that is why it is called as, sometimes it is called as Heine laser. And this Heine laser will have a specially designed discharge tube, and here the specially designed discharge tube is shown, and this specially designed discharge tube is fitted with two electrodes, and this electrode is anode and this electrode is cathode, and we apply a power supply between these two electrodes. Then the discharge tube is filled with the helium and neon gases at low pressure, and the discharge tube is placed between the two reflecting mirrors. Then we look at the advantages of this helium neon laser. Advantages are low cost, and then they can be operated at high temperatures also, and they are normally used, they produce laser beam of visible region, that is one advantage. Then the disadvantages of this laser are as follows. The efficiency of this laser is very less, and the gain of the medium also less, and it is normally used for only low power applications. Now let us see the applications. It is used in industries, and it is used in scientific instruments, and it is used in college laboratories. Okay, now I want to explain the different components present in different lasers. So first of all, we will go to the notepad. We know that any type of laser contains three components. The first component is active medium. And we know that active medium is the material that should have a suitable energy level system in which population inversion can be achieved. For example, in case of ruby laser, we have the active medium. So ruby crystal is the active medium in case of ruby laser. And then carbon dioxide molecules are the active medium in case of carbon dioxide laser. And then the semiconductor material such as gallium arsenide material is the active medium in case of semiconductor laser. And then the active medium is neodymium ions, Nd ions. Nd ions are the active medium in case of ND-YAG laser. Like this, we can talk about active medium of a laser source. Then the second component of laser source is pumping system. Pumping system is the method or means to achieve the population inversion. Now, there are several methods to achieve population inversion in a laser. For example, the xenon flash lamp produces pumping population inversion in case of ruby laser. And then the forward bias causes in case of semiconductor laser. Forward bias causes population inversion in case of semiconductor laser. So in case of ND-YAG laser, the Krypton flash lamp will act as pumping system in case of ND-YAG laser. Then the third component of laser is optical resonant cavity. Optical resonant cavity is the third component. So this component is required because we want to eliminate the spontaneously emitted photons from the medium, because spontaneously emitted photons, they travel in different directions. We have to eliminate them. Then the second thing is we have to have multiplication of stimulated emissions, and then we should provide a direction for the emitted laser beam. All these three things are achieved by this optical resonant cavity. And what is this optical resonant cavity contains? It is simply by taking the active medium in the form of a long rod, and by placing this long rod in between two reflecting mirrors. Then out of the two reflecting mirrors, one mirror is 100% reflective and the other mirror is partially reflective. And finally, the laser beam comes out from the partially reflecting mirror, and in that way we are providing direction for the emitted laser beam. And because we are taking the active medium in the form of a long rod with small cross section, because of the small cross section, the spontaneously emitted photons that are traveling in different directions, they immediately leave the medium. And further, because of the mirrors, the photons moving back and forth, that means the mirrors actually causing feedback of photons to the medium, and the feedback of photons to the medium again causes multiplication of stimulated emissions. And because of the multiplication of stimulated emissions, the light intensity builds up, and when light intensity permanently builds up to a very high value, that is called resonance condition, a laser beam comes out from the this partially reflecting mirror. Like this, we can explain the working of this optical resonant cavity component. So that is about this helium neon laser, and I told about the construction of a helium neon laser, the working of helium neon laser, and we also saw the different applications of helium neon laser, and we also discussed about the components of any type of laser. So these are the three components required for any component of laser. So that is about the helium neon laser. So thank you very much.